Greetings and welcome to Education and More's Learn Python 3 Programming at a Snail's Pace. My name is Marcus Gardner and I'm the instructor for this course. In today's video, we're going to continue with the solution of Finding the Town Drunk by Barney Fife. Okay? And this is our review of putting it all together. Okay. This is the second video. In the first video, I explained the problem in detail. In today's video, we're going to go over creating the initial position of both of those characters. And then we're going to do one more function, okay? And then in the next video, we'll continue doing more. I'm trying to break it up so it isn't too long. You'll notice some small discontinuities in the videos. You know, for example, my shirt changed. That's because I made the first video way too long and I had to come back and insert these greetings. So I do apologize for that. I'm not a very good recorder, but I got so carried away with teaching I forgot. It's like well over an hour for one video, way too long. So had to go back and cut it, and it doesn't look all that great, but hope you'll forgive me for that, and hopefully you'll continue on these lessons even if my video mistakes are not so great. Okay, so let's get started, and here's the next part of the video. Okay. All right, so next, we need to get starting positions. Okay. Now, so let's go ahead and get started. So let's see here. File, new. Lesson 10. Oh, file, save as. Here, lesson 10. And P down 6. Okay, save. Now, we want to be able to get the starting positions, okay? And Otis is going to use a random number. So the first thing we need to do is import random, okay? So import random, okay? Now, we are going to call a function to get that information, starting positions, okay? So let's call that starting positions. Now, we're actually going to get some return values, so we're going to have something equals. I don't know what that is yet, but we're not going to pass it anything. So we need to define starting positions. Okay. Now, oops, I need a colon. We're going to do Otis first. Okay. So x Otis is equal to random dot rand int. We're going to pass it the smallest value and the largest value. Of course, you're free to change this, you know, play around with it, see how long it takes to find them with a much bigger field. Okay, y Otis equals random dot rand int -20. I should have just copy pasted, but anyway, that's okay. Now that's Otis. We are done. Okay. Now we got to get user from the input. Okay. Get input from the user. All right. Anyway, so this is going to be x Barney is equal to int input enter starting x position between -20 and 20. Okay. All right, that takes care of that. And then y Barney is equal to int input enter starting y position. Again, I should have copy pasted, but oh well. There we go. Okay, and then we need to return some values. So return, we're going to return X Otis. I don't need to do that. I like this. I forgot about that. And then X Barney and Y Barney. Okay. So I'm going to put this over here. Now remember, they do not have to be the same variables. I could have called this X position Otis, Y position Otis. The names don't have to be the same. What's important is the relationship. This is X Otis. This needs to be whatever's referring to X Otis. It can't be X Barney. Okay, it can't be Y Otis. Okay. All right, that's the only thing that's really important. All right, now, if this was just something for you, you're done. However, let's pretend this is for a boss or for code review. Then we want to put a few comments in here. Now, I've seen some programmers put the comment as the function name, but why? The function name is right there, okay? So I don't even use function name, okay? I mean, if you can't read the next line and say it's a function name, then I don't want you code reviewing for me, all right? So I might do something like this. Input, none. Output, X, Y of Otis, followed by X, Y of Barney. Okay. Something Otis is randomized and Barney is input from user. And that's all you really need. Okay? You do not need to explain how you're doing each of these functions. Okay? This is enough for your code review. They know, oh, okay, good. It says here input none. You have input none. Output X, Y of Otis. Well, this is not really parentheses, but oh, he's just doing shortcut. The X coordinate, Y coordinate, whatever, okay? And so they say Otis followed by Barney. So yeah, oh, this looks good. And then they said Otis is randomized. Oh, okay, so this is randomized and this is input from user. That's all you need. All right, so, but again, we really need to proof it so that, you know, my code reviewer might say, aha, I'm going to put in an A and see what happens. Okay, so we need to make sure my code reviewer can't break my code. All right, so we're going to do a try statement here, and that means we need to tab those over, and then we're going to put an except clause in here. And then we're going to say print, please enter only an integer from -20 to 20. And that's it. But in order to do this, we need to do a while loop. So while something happens, so let's just say good. Is it good or not? So let's try good is equal to 0 while good is equal to 0. And then let's tab all this over. There we go. But the except, it's only so smart. It's not as intelligent as a person. Okay, it's not going to say, oh, I need it to be an integer and between -20 and 20. Okay, I'm sorry, but the computer's not that smart. Okay, it's not going to be able to read your code and know what you're planning. Okay, the only except that's going to cause problems are, one, if you put in strings or you put in, you know, things that are not integers like floats. Okay, so it's not going to know it's a problem if you type in -30 or 1000. So you have to put in your own. So I'm going to do that here. I'm going, now, okay, you do it. Pause the video and write me only one if statement. that will check to see if both X Barney and Y Barney are within the bounds of negative 20 and 20. Okay? 3, 2, 1. Okay, hopefully you paused the video enough and gave it a try. Remember, the only way you're really going to learn is if you try this. So if you're just sitting back, okay, I'm waiting, show me the answer, show me the answer, you're not going to become a programmer. I'm sorry. It just doesn't work that way. You have to actually get your hands dirty, but not really unless your keyboard is dirty, like mine. But anyway, you have to actually do some coding. Okay? All right. So, if X Barney is greater than or equal to negative 20, and X Barney is less than or equal to 20, and Y Barney is greater than or equal to negative 20, and Y Barney is less than or equal to 20. Okay? Then I'm going to, what do I need to do? I want to say that's good, so we need to do a good equals 1. Okay? Now, this would be okay, but it's not really telling the customer what's wrong if they don't do it correctly. Let's say they type in 200. It's going to go back to enter starting position, and they're not going to know what they did wrong. They didn't read it the first time. What makes you think they're going to read it the second time? So, we need else. Print, please enter integers between negative 20 and 20. Exclamation points. Please read my instructions. Okay? And that's it. That's all we really need. But now, to be a good programmer, you should test it. This was the difference between me and my fellow programmers when I worked for Equifax. Some of them were better than me. You know, I couldn't compete with that. But what I could compete with was the returns from QA. Okay, they all like to program the whole thing and then test it. Okay, I tested it piece by piece. So, in the 8 years that I worked at Equifax, I had 1 return from QA in 8 years. Why? Because I tested code function by function. Okay? All the other programmers had 1 or more a month. Okay? I am not saying I was better than them, but what I could do was test better. Okay? So that was a big difference. Okay? And I think that helped me get promoted because every quarter they would review, look at the mistakes, how many mistakes, how many mistakes. Hey, this is 0. Okay? So I was slower than them because I tested a lot. Okay? I didn't like testing. Now, I'll be honest with you. Coders don't like testing. Okay? But I knew I couldn't compete with the other programmers as for coders. They're better than me. They were better than me. No doubt about it. Okay? So the only way I could compete with them was testing. Okay? So it saved a lot of time because then you have to go back to QA, and it, you know, when you get done with a project, you're given another project, and if it comes back from QA, you got to put that other project on hold, and you got to go back and find your errors, and that takes time. Okay, so please do what I did. Test it function by function, if at all possible. Now there are some functions that really need another function, so you can't test it until you've done the other function. Okay, but anyway, let's go ahead and give it a try. Okay. Because maybe I made a mistake. It's very possible. Okay. All right. So let's see here. Oh, I'm not done here. I need to print something. Otherwise, I won't know it worked. Okay, so print Barney started at X Barney, comma, Y Barney. I'm trying to make sure I don't get a mistake here. Comma, there. And Otis started at, comma, X Otis, comma, Y Otis, comma, there we go. I think I did that right. All right, we're going to find out in a minute. Okay. We'll clean up the code in just a minute here. Okay, Python, and this is Lesson10.py. Starting position, A, only integer, good. How about 1.5 or 1.2? Okay, good. All right, so I'm going to say 0, 1. Okay, Barney started at 0, 1, and Otis started at -8, 3. Hey, great. Okay. All right, next. Let's clean this up a little bit. Delete. Okay. So now, what are we going to do? All right, so we got the starting positions. Now we need to know a certain while loop so that we know whether we are done or not. Okay? So can you think of a good while loop? Now, we don't want to introduce other variables if we don't have to. Okay? So what we're going to do is we're just going to say, while the positions are not equal, continue on. Because perhaps, it's theoretically possible that Otis's random position was my Barney's starting position. And say, oh, I'm here. You're here. I caught you. Okay? So, otherwise, we'd have to have that as a separate case. So, what I'm going to do here is say, while X Otis does not equal to X Barney, or, okay, the very first time I coded this wrong, and I put and, okay, or Y Otis doesn't equal to Y Barney. I'm going to keep going. Okay, because remember what's happening here. I want both of them to be the same, and I want both of them to be the same. So if either one of these two is wrong, I wanted to keep going. Okay? You okay with that? I hope so. All right. Okay, so now the very first thing you want to do is determine the direction. So we're going to need a function that will tell us to either go up, down, left, right, or north, south, west, east. However way you want to do it, okay? So first thing we want to do, let's call that, we're going to get just the direction. And let's see, get direction. And we are going to pass it these variables here. 4 variables, okay? All right, so now we need a function. Define, and I'm just going to pass it all of this. Again, the variable names do not have to be the same. I could call these 4 other items if I wish. For me, it's just easier if I just keep them the same. Okay? All right. Now let's go back to my little problem here. Now, there's a couple scenarios we need to worry about. One is the most general one. Here's Otis. Here's Barney. Great. Okay. We've already talked about the triangle thing. We know that the smallest distance is the one we want to go in. Okay. But it's the end cases that get many programmers into a bind. They forget about the end cases. Okay. And that happens a lot with strings, which we'll talk about later. We haven't talked about strings much. Yeah, we printed strings, but we haven't worried about other things. But anyway, we'll worry about end cases for those type of things later. But right now, we're going to talk about points. What if we had a defunct triangle? Well, as you know, a triangle is like this, okay? Well, let's move this here. We call this a defunct triangle. It's no longer a triangle, okay? So now we don't want to go any way except this way. So we don't need to test anything. Because if we test shortest distance, well, this is shortest. We don't want to go shortest. Okay, we're going to go this way now. So we need to do a specialized case. The case where it's horizontal to each other or vertical to each other. Okay? So that needs to be a special case. All right. So now we need to do the special case. So how do we do that? We need to check first off if the x's are the same. Okay? So if x Otis is equal to y Otis, then we are going to see, I'm sorry, x Otis is equal to x Barney. I was going to say, what in the world? All right. Now, we don't need to worry about checking if y Otis is equal to y Boney now, because we've already checked it here. That's what this does. Because if they were both equal, we've already found them. Okay? So if x Otis is equal to y Barney, now what we're going to do, so go back to our graph. So that means this is the situation, okay? I'm here and he's here, okay? All right. Now, but the question is am I here and this is him, or am I here and this is him? In other words, is he above me or below me? So that's important because I want to move towards him, not away from him. Okay? So I need to say here, okay, that if x Otis, or y Otis, sorry, if y Otis is bigger than y Barney, I want to move up. Okay? So I am going to return up, because that's the way I want to go. Otherwise, return down. It has to be one of those two, because I've already clarified that we are vertical. So either he is above me and I need to move up, or he is below me and I need to move down. I don't have to worry about where he's at, the same at me, because otherwise my while loop would have been finished. Okay? So that takes care of the x Otis and x Barney being the same. Now, what about if y Otis is equal to y Barney? Okay, again, that's this way. The y's are the same. So again, is he on the right or left side of me? Okay. Then I need to say if X Otis is greater than X Barney, then return right. Else return left. Okay? All right. Now, I have this as if and then if. I could put elif here. Okay? It doesn't matter in this case because if it goes into here, I am not going to hit here because both of these cases are going to return something. Okay? But it usually is best to put elif here. But I know for a fact that if this is true, this will not get executed. So it acts just like an elif. Okay? So you can put elif here if you want. I'm not going to for this case because I know that if this is true, this is not going to get executed. Okay? All right. Now we have the hard one. Okay? Now we have to decide which side is smallest because that's the way we want to go. So what I'm going to do here is I'm going to say if the position of X Otis for the X side here is greater than the X position of the Barney, I am going to say that the direction for X has to be equal to right. Okay? Because, you know, if he is to the right of me, I need to go right. Okay? All right. So, now that's not the only thing I want to do. I want to find a distance. So I'm going to say the distance for X is equal to X Otis minus X Barney. Okay? Else, I'm going to copy this and paste it and say left. Okay? Otherwise, you know, Barney is to the right. Okay? So we want to go left. And again, the distance, oh, we got to change this here. Control X, Control V, put a minus there, take care of that. Okay, good. Now we want to do the exact same thing for the Y parts. If Y Otis is greater than Y Barney, then we're going to say direction of Y is equal to, now Otis is bigger, so we want to go up. Okay? And distance for Y is equal to Y Otis minus Y Barney. Else, I'm just going to copy paste this. Oh, I got to put the screen up so you can see it. Sorry about that. There we go. Okay. Otherwise, that, except now we're going to change this to down. And let's take, whoops. I don't know if I did it right. Anyway, there we go. Yes, I did it right. Okay. Now, why did I do that? Well, I'm finding the distance of X. Okay. Later on, we'll find a better way to do this when we use absolute value. We don't have to do this distance X calculation twice. But anyway, until we learned about absolute value, we had to do it this way. Okay. And then we're finding out, well, what direction we would need to go. But we still don't know which of these four to choose. Well, that's okay. Notice I have direction X only defined once. Okay? Whichever one is true. Okay? So it's not going to replace each other. And then I have direction Y only defined once. So all we need to do is see which one's smaller. So if distance Y is less than distance X, then I'm going to return direction Y. Else, I'm going to return direction X. Okay? And that's it. So this was a little complicated. So it's very important that you go back over this code and see what happened, okay? All right, now what we're going to do is test this. Print direction is dir. Okay, and let's give it a try. Oops. Okay, let's break. Hey, I didn't think we were going to use break in this code, but we are. Okay, so let's make this a little bit smaller now. Okay, so print direction is dir, and now we're going to break. So in other words, only going to do it one time. Try it again. Okay, Otis is here. We said the direction is right. Well, the distance here is 10. That's smaller than 15. Okay, so yes, we do want to go to the right. Let's try it again. It says here direction is up. Notice 0 to 3. This is smaller, so we want to go up. Try again. Okay, this one times this direction is down. 0 to negative 10. Okay, so down. Okay, I don't think my luck's going to hold out and give me a left here. It would be nice, but no. Let's see if we can get a left up here. It may take a while. Direction is right. Oh my goodness. There is a way I could force it, but let's just see naturally if I can get this thing to cooperate. All right. Let's force it, or at least give it a lot better chance, okay? So we're going to starting position 20, 0. Oh, 20. That was not what I wanted. Let's try it again. 20, 0. There we go. Direction is left. Okay. All right. So that has 12, and this is 17. So that's the problem you get when you try to test something thoroughly when you're dealing with random numbers. Sometimes it just doesn't want to cooperate. Okay. Now, it should have happened, once every 4 times. Okay. But again, randomized, it could really take quite a bit of time. So that's why I forced it here. Now, if this hadn't worked, then maybe there might have been something wrong with my code. So that's why it's important to test it in chunks. Okay. All right. Let's see. So let's go on. So now that we have the direction, we want to make a move. Okay? We know which side to go. So now we just need to make a move. Okay, we're going to stop it right here, and we're going to continue the rest in the next video. All right, thank you very much. Have a nice day. Bye-bye.